Identifying electrical leads, specifically brown, yellow, and orange wires, requires a systematic approach using a multimeter and other techniques while prioritizing safety. Firstly, before starting any electrical work, ensure safety by turning off the power at the breaker panel. Verify the power is off using a non-contact voltage tester. Wear appropriate safety gear such as gloves and safety glasses. Secondly, prepare your multimeter by setting it to AC voltage mode. Connect one probe of the multimeter to the hot wire, typically black or red. Connect the other probe to each of the colored wires, one at a time, starting with the brown, then the yellow, and finally the orange wire. The wire that shows the highest voltage reading is the orange lead. In a standard electrical system, the orange lead is the hot conductor. To differentiate between the brown and yellow leads, consider the circuit type. If the circuit is a 120-volt circuit common in North America, both brown and yellow wires are typically neutral conductors. If the circuit is a 240-volt circuit, brown may be the second hot conductor and yellow may be neutral. Inspect the wire insulation for any markings. In some cases, the brown and yellow wires may have different colors of insulation at the ends. Check for any markings on the insulation, such as N for neutral or H for hot. If the circuit is de-energized, you can use a continuity tester to determine which wire is connected to the neutral bus. Connect one probe to the white neutral wire at the panel. Touch the other probe to brown and yellow wires one at a time. The wire that shows continuity with the neutral bus is the neutral wire, typically the yellow wire. The remaining wire is then identified as the brown wire. Remember that wire color codes can vary by region and application, so always verify your findings with reliable testing methods. When using a multimeter, the AC voltage setting measures the alternating current voltage between 2 points. It is crucial to ensure the multimeter is set to the correct voltage range to avoid damaging the meter or obtaining inaccurate readings. A non-contact voltage tester can detect the presence of voltage without physically touching the wires, providing an added layer of safety when verifying that the power is off. Continuity testing is a method of checking if an electrical path exists between 2 points. A continuity tester sends a small current through the circuit and indicates whether the circuit is complete or broken. When testing for continuity, ensure the circuit is de-energized to prevent damage to the tester or injury. In a typical 120-volt circuit, the black or red wire is the hot conductor, the white wire is the neutral conductor, and the green or copper wire is the ground conductor. In a 240-volt circuit, there are two hot conductors, typically black and red or brown. The neutral conductor is usually white or yellow. The ground conductor is always green or bare copper. Always consult local electrical codes and regulations for specific requirements in your area. Electrical work can be dangerous, and it is essential to follow all safety precautions to prevent electrical shock or fire. If you are not comfortable working with electricity, consult a qualified electrician. Before working on any electrical circuit, identify the circuit breaker that controls the circuit and turn it off. Test the circuit to ensure that the power is off before proceeding. When working with wires, use appropriate wire strippers to remove the insulation without damaging the conductor. Make sure all connections are secure and properly insulated. When connecting wires to devices, follow the manufacturer's instructions and use the correct type of connectors. Never overload electrical circuits. Overloading can cause wires to overheat and potentially start a fire. If you are unsure about the capacity of a circuit, consult a qualified electrician. Keep electrical panels and outlets clear of obstructions. Do not block access to electrical panels or cover outlets with furniture or other objects. Regularly inspect electrical cords and appliances for damage. Replace any cords or appliances that are damaged or worn. Use ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor areas. GFCIs can help prevent electrical shock by detecting ground faults and immediately shutting off the power. In addition to the methods already described, you can also use a wire tracer to identify wires in a circuit. A wire tracer consists of a transmitter and a receiver. The transmitter sends a signal through the wire, and the receiver detects the signal, allowing you to trace the wire's path. Wire tracers can be particularly useful in complex wiring systems where it is difficult to visually identify wires. Another helpful tool for identifying wires is a wire map. A wire map is a diagram that shows the connections between wires in a circuit. Creating a wire map can help you understand the wiring system and troubleshoot problems more easily. When working with electrical wiring, it is important to understand the different types of wire insulation. The insulation protects the conductor from damage and prevents electrical shock. Common types of wire insulation include thermoplastic high heat resistant nylon coated, or THHN, thermoplastic high heat resistant water resistant, or THWN, and cross-linked polyethylene, or XLP. Each type of insulation has different properties and is suitable for different applications. When selecting wire for a particular application, it is important to consider the ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry. The ampacity of a wire depends on its size, material, and insulation type. Use appropriate wire connectors for the wire size and type you are using. Wire connectors ensure a secure and reliable connection between wires. Common types of wire connectors include wire nuts, crimp connectors, and push-in connectors. Always follow the manufacturer's instructions when using wire connectors. When working with electrical boxes, make sure the boxes are properly grounded. Grounding provides a path for fault current to flow back to the source, helping to prevent electrical shock. Metal boxes are typically grounded by connecting a ground wire to a grounding screw in the box. Non-metallic boxes may have a grounding terminal for connecting a ground wire. Do not use damaged electrical equipment. Replace any equipment that is cracked, broken, or otherwise damaged. Damaged equipment can be hazardous and may not function properly. If you are working on a circuit that has multiple voltage levels, be extra careful to avoid accidental contact with higher voltage conductors. Higher voltage can cause serious injury or death. When working on a multi-wire branch circuit, be sure to identify the neutral conductor correctly. A multi-wire branch circuit shares a common neutral conductor between two or more hot conductors. If the neutral conductor is not properly connected, it can cause voltage imbalances and potentially damage equipment. It is also crucial to understand the different types of electrical circuits. A branch circuit is a circuit that extends from the circuit breaker panel to the outlets and devices in a room. A feeder circuit is a circuit that supplies power from a service entrance to a subpanel. A service entrance is the point where electricity enters a building from the utility grid. When working on electrical circuits, it is essential to understand the relationship between voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of current. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. When selecting electrical components, such as circuit breakers and fuses, it is important to choose components that are rated for the appropriate voltage and current. Using components that are not rated properly can lead to equipment failure and potentially cause a fire. Another important consideration is the National Electrical Code, or NEC. The NEC is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, and it is important to follow the latest edition when working on electrical installations. Some key sections of the NEC include Article 210, which covers branch circuits, Article 220, which covers branch circuit, feeder, and service calculations, and Article 250, which covers grounding and bonding. In addition to the NEC, there may be local electrical codes that you need to follow. Local codes can vary from jurisdiction to jurisdiction, so it is important to check with your local building department to find out what codes apply in your area. When making electrical connections, be sure to use the correct tools and techniques. Proper connections are essential for ensuring safe and reliable electrical service. Use wire strippers to remove the insulation from the wires without damaging the conductors. Use wire connectors to join the wires together securely. Use a torque wrench to tighten the connections to the proper torque. It is also important to protect electrical wiring from physical damage. Run wiring through conduit or other protective enclosures where it is exposed to physical hazards. Protect wiring from moisture and corrosive substances. Use appropriate supports to secure wiring in place. When working with underground wiring, be sure to call your local utility company before digging to avoid damaging underground utilities. Underground utilities can include electrical lines, gas lines, water lines, and communication cables. Damaging these utilities can be dangerous and can disrupt service to your home or business. If you are installing new electrical wiring, be sure to obtain the necessary permits from your local building department. Permits are required for most electrical work, and they help to ensure that the work is done safely and in accordance with the applicable codes. When the electrical work is complete, have it inspected by a qualified electrical inspector. The inspector will verify that the work meets the requirements of the NEC and local codes. A passing inspection is required before the electrical service can be energized. Furthermore, understand the specific color coding used in your region or application. While general guidelines exist, variations can occur. Always double-check with local codes and regulations to ensure you are following the correct procedures for wire identification. If the insulation on the wires is damaged or deteriorated, replace the wires. Damaged insulation can create a safety hazard. When replacing wires, use the same gauge and type of wire as the original wire. If you are unsure about the correct wire size, consult a qualified electrician. Use cable ties or other fasteners to keep wires organized and prevent them from becoming tangled. Tidy wiring is easier to work with and reduces the risk of damage. Label wires clearly to identify their purpose. Labeling can be helpful for troubleshooting and future maintenance. Use a permanent marker or label maker to create durable labels that will not fade or peel off. When working with low voltage wiring, such as telephone or data cables, be careful not to damage the insulation. Low voltage wiring is typically more delicate than high voltage wiring. Use appropriate tools and techniques to avoid damaging the wires. If you are installing a new electrical outlet, be sure to choose an outlet that is rated for the appropriate amperage. Outlets are typically rated for 15 amps or 20 amps. Use a 20 amp outlet for appliances that draw a lot of power, such as refrigerators or air conditioners. When installing a new light fixture, be sure to use the correct type of bulb. The light fixture will have a label indicating the maximum wattage of the bulb that can be used. Using a bulb with a higher wattage than the fixture is rated for can create a fire hazard. It is also important to understand the different types of electrical panels. A main panel is the panel that receives power directly from the utility company. A subpanel is a panel that receives power from the main panel. Subpanels are used to distribute power to different areas of the building. When working on electrical panels, be extremely careful to avoid contact with live parts. Electrical panels can contain high voltages that can cause serious injury or death. Always turn off the power to the panel before working on it. If you are not comfortable working on electrical panels, consult a qualified electrician. When working with electrical equipment, be sure to follow the manufacturer's instructions. The manufacturer's instructions will provide important information about the safe and proper use of the equipment. Read the instructions carefully before using the equipment. If you have any questions about the equipment, contact the manufacturer or a qualified electrician. Regular maintenance is essential for ensuring the safety and reliability of your electrical system. Have your electrical system inspected by a qualified electrician every few years. The electrician can identify potential problems and make repairs before they become serious. Keep your electrical system clean and free of dust and debris. Dust and debris can accumulate on electrical components and cause them to overheat. Replace any worn or damaged electrical components. Worn or damaged components can be a safety hazard. If you have any concerns about the safety of your electrical system, consult a qualified electrician. A qualified electrician can assess your system and make recommendations for improving its safety. By following these safety tips, you can help to prevent electrical accidents and ensure the safety of your home or business.